Alright, this is the warm-up that will get you ready for your quiz, just the 8.3 part of the quiz, which will just be the front side of the quiz that you'll get, where we just talked about how can we decide if a given quadrilateral, where they give us some information in that picture, if it's a parallelogram or not. We have to justify our reasoning. So if we say yes, we have to say why it is. Okay? So go ahead and pause this, and you guys take about, should only take you about 4 minutes to work on this warm up. All right, so let's go over this. And so remember, there were 5 ways to show that parallelograms, or I'm sorry, to show that quadrilaterals were parallelograms. One way was to show that you have 2 pairs of opposite parallel sides. Another one was showing that you have 2 pairs of opposite sides that are congruent. Another one is to show that you have 2 pairs of opposite congruent angles. Another one was showing that the diagonals bisect each other. So those were the first one that I said about the parallels, that was the definition, and then the other 3 I just stated were characteristics of parallelograms. The last one that was new was just if you had 1 pair of opposite sides that were both parallel and congruent. And so then if we look here, on number 1, we've got a quadrilateral where we have 2 pairs of opposite parallel sides. So yes, this is a parallelogram, and it's because you have both pairs of opposite sides are congruent. Okay? Should be a congruent sign there. Okay? Alright, so this one, you have 1 pair of opposite sides that are both parallel and congruent, so that answer is yes, it's a parallelogram. 1 pair of opposite sides are both congruent and parallel, because that was one of the 5 ways to show that you have a quadrilateral as a parallelogram. All right, number 3, just showing that you have 1 right angle does not justify that this is a parallelogram. Okay, that's not one of the 5 ways to prove that you have a parallelogram. So this would be not a parallelogram. It's not one of the 5 ways we talked about last time that proves that you have a parallelogram. So your quiz will be similar to this, where you need to know those 5 ways to prove that quadrilaterals are parallelograms, and being able to say then which one it was. If you say yes, and if you say no, you would just say not a parallelogram. Okay? Alright, so now take out your 2 worksheets. You had your special quadrilaterals, where there was now more problems that you could finish on there, the one with the rhombus and the square on it. And then also your 8.3, 8.4 worksheet, where you did numbers 1 through 4, and then the last 2 graphing problems. So take that out. Alright, so first I'm going to look at the special quadrilaterals worksheet, and I'm looking at the section that had the rhombus, so numbers 15, 16, and 17 on that special quadrilaterals worksheet. And I'm only going to do a couple on this one, but my recommendation on here is for you to mark what the definition says about whatever this figure is. So rhombus, the definition of a rhombus said that it's a quadrilateral where all 4 sides are congruent. And then also the special characteristics that just go with rhombus. And so there were 2. It said that the diagonals of a rhombus are perpendicular, and it said that the diagonals of the rhombus cut them in half. So that and that are congruent to each other, and this bisects this bigger angle, so this and this will be congruent to each other. I could mark the other ones, but I'm just going to mark the ones that they put. But I could put double arcs on these 2 little angles and single arcs on these 2 little angles. And so I recommend that you mark the part about what their definition says. So definition of rhombus said you had 4 congruent sides, and then mark their special characteristics. Now it still has all the characteristics that a parallelogram has, where the diagonals bisect each other, opposite whole angles, so this whole angle P is congruent to this whole angle U. So all the characteristics of parallelogram, but I'm going to mark just the ones that are specific to the rhombus. So then that's going to help you solve these problems. Okay, so then I'm going to look at this one. So measure of angle SXU. So if you follow SXU, well, we know diagonals are perpendicular in a rhombus, so then that angle is 90 degrees. So if you mark your picture with what you know, it makes the problems easier. All right, on this one, if the measure of angle 1, right here, is 3x plus 1 degrees, and the measure of angle 3, so that's this double arc up here, is 7x minus 11, then we want to know what's x equal and what's the measure of angle 2. All right, let me change colors here. So I know, since we marked in our picture, that angles 1 and 2 are the same. So then if angle 1 is 3x plus 1, angle 2 is also 3x plus 1. Well, now you've got this right triangle right here. Right here. And we know it's a right triangle because the diagonals are perpendicular. And so I know angle 2 is 3x plus 1, angle 3 is 7x minus 11, and this angle right here is 90. What do we know that the sum of the interior angles of a triangle have to add up to equal? 180. So I'm going to do 3x plus 1 plus 7x minus 11 plus 90 equals 180. So this is a right triangle that I outlined in blue here. So this angle plus this angle plus this angle is 180. So I'm going to combine like terms. I've got 10x. 1 minus 11 is negative 10 plus 90 is 80 equals 180. And then if I minus 180, so 10x equals 100. Divide by 10, x is 10. So that's my first blank. Then I need to find measure of angle 2. Well, we know angle 2 and angle 1 are the same. So I'll do 3 times 10 plus 1, which is 31 degrees. Okay? All right, so that's the rhombus. Now let's look at the other one, which was the square. Now the square has every characteristic that a parallelogram has, every characteristic a rectangle has, and every characteristic that a rhombus has. So it'd be a lot to mark in there, but at least we know the definition for a square says that all the sides are congruent, and we know that these are all right angles. So I'm going to put some of this stuff in here. I also know that because it's a square, it also does what a rectangle does, which means this whole diagonal from M to R is equal to this whole diagonal O to E. And then I can also mark it to show that, how we did in rectangles, is then I could show, I would know, oh, this thing's not working very well. It's like shaking like crazy. Let's try again here. So I can mark all these with doubles. Why is this thing shaking like crazy? And so we have that marked, okay? And so I'm just going to do one of these. Let's see. This talks about ME and MO. So ME and MO, that'll be easy. Those are congruent sides. Let's look at this one. So MT is from here to here, and that's 4x. See if I can write that up. Oh my gosh, why is this being crazy? Let's try that. Does not want to work for me today. All right, trying to get this back to work. So MT is 4x and TE is 3x plus 2. And since diagonals bisect each other and the whole diagonals are congruent, diagonals bisect each other because of parallelogram piece, and the diagonals are congruent because of the rectangle piece, and so I'm going to set those two equal to each other. So 4x equals 3x plus 2, so minus 3x, x equals 2, but that's not what they wanted. They wanted OE, so OE is the whole diagonal, so let's plug it in here. So 3 times 2 plus 2 is going to be 8, so this is 8, which means this is 8. So the whole thing from O to E should be 16. Okay? All right, so that was the rest on that one that was for the special quads. So again, on your test next Thursday, or this coming up Thursday, you are going to need to know the characteristics of parallelograms, rectangles, rhombuses, and squares, and then how to use those characteristics to be able to put them in pictures and solve some variables and side links and whatever they ask, like they did on the special quads worksheet. So that's good practice for the test. All right, then the first 4 was just what we covered in section 8.3, was talking about when to show if a quadrilateral is a parallelogram or not. Okay, and so we had to draw a picture each time. If you read the directions, you're supposed to draw a picture and then mark the information and tell whether or not the conditions show that it's a parallelogram or not. Okay, so I have quadrilateral MNOP, and you can draw any 4-side figure you want. MNOP. And you could either start at one point and go clockwise, or start at a point and go counterclockwise. You just can't go across. I couldn't do like MNOP or anything like that. So MN is parallel to PO, so put arrows there. And segment MN is congruent to segment PO. So congruent, you put slashes. So based on those markings, and I could have put the diagonals in if I wanted to, but I didn't need them here because where they intersect is point Q, and I didn't have anything about point Q here, so that's why I didn't draw them in. And so this is one of those cases where the one pair of opposite sides are both parallel and congruent, so this would be yes, because one pair of opposite sides are both, or yeah, one pair is both parallel and congruent. Okay? And so for all of these, you are drawing a picture, and then from that picture deciding if it's one of the ways to show that it's a parallelogram. So I'll just do one more of these. I'll do this one. Or no, wait, hold on. Let me do one that has the Q in it. So let's do number 3. So number 3, I've got MNOP. I know MN is parallel to PO. And since it brought in Q here, I need to draw in the diagonals. And it says the diagonals intersect at point Q. So then I know that segment PQ is congruent to segment ON right here. Okay? So this definitely is not anything that was showing that a quadrilateral is a parallelogram. So not a parallelogram. Because that's not one of the 5 ways that we showed we had a parallelogram. Okay? So that's what you do on 1 through 4. Draw the picture, mark the given information, and then decide if that's one of the 5 ways to prove that a quadrilateral is a parallelogram. Okay? The last 2 problems where was the coordinate geometry stuff, where they give you a picture on the coordinate plane, and we have to decide if it's a parallelogram and justify our reasoning. So you did one like this on our example 2 that we did in our notes. Now you could probably tell just by looking at it that this one is a parallelogram and this one is not, but you do have to justify your reasoning. This is kind of what we call coordinate proof, where you have to give me some proof. We don't have to do it in 2-column proof style and give reasons and all that kind of stuff, but we do have to have some reasoning behind and show some work on what we're doing. So it really doesn't matter. I'll do the one that looks like it's a parallelogram. And so we could show any of the 5 ways like either opposite sides are parallel, opposite sides are congruent,